This chapter is about bladed spokes. If you're going to build or service wheels with bladed spokes, there are some things you need to know to make sure you don't damage the spokes. First of all, let's say I want to tension this spoke here. This is the Park tool that works with this Mavic special type of a nipple, which fits right on here. Because the spoke is bladed, I want to make sure that I hold the spoke stationary so that the spoke does not twist as I turn the nipple to tighten or loosen the spoke. This little Park tool here, the BSH, which stands for Bladed Spoke Holder 4, the BSH4, is a nice tool that has 4 different size slots in it, depending on what the width of the bladed spoke is that you have to hold. Spokes like Sapim CX-Ray spokes and DT Swiss Aerolite spokes are quite strong, but they're also very thin. These spokes have dimensions of on the order of 0.9 millimeters by 2.3 millimeters. Let's say I want to tension this spoke here, and I use a spoke wrench that fits perfectly on the nipple, and then I put my spoke holder up here. But my problem is this, especially as the tension gets high, as I turn this nipple here, I have the possibility of putting a permanent twist in this 1.5 or 2 inches of unsupported spoke. If that happens, you've created a stress riser and a fatal flaw and weakness in the spoke, and it has to be replaced. So we have to use a different setup when we're working with these kinds of Sapim CX-Ray or Aerolite spokes. These are 2 Sapim CX-Ray spokes. The one on the right is the normal one. The one on the left has a 90-degree twist in it because of somebody using an improper type of spoke wrench and trying to true a wheel. Here's one where a spoke has been twisted around a couple of times. This is one way of doing it. Let's say I'm going to put some more tension on this spoke here. I'm going to use a 4-sided spoke wrench, which is a good idea anyway, especially if the tension gets high. And then I'm going to take this tool here, and this will slide all the way down on the spoke, and I'm now supporting the spoke over its entire length of the bladed section, so I can turn this spoke wrench here with confidence that I won't twist the spoke. Another combination of tools that works very well is to use a 4-sided spoke wrench like this, which fits down on the nipple. And because this works by going around this way, I can hold the spoke much lower, either with the Park tool I showed you a minute ago, or this little, I think very convenient spoke holder that I got from the United Bicycle Supply. What I do actually with my Cyclist wrench, Cyclist is a German tool company, is I take this and go to a bench grinder, and I've ground off about the top half of that knob there. And when I use that, you can see that the ability for the tool as I'm turning it to slide under the holder is even better. So I have great confidence that I have adequate support for the spoke because I'm now holding it all the way down at the bottom of the bladed portion. This is very important when you're using these kinds of spokes. You don't want to be building or servicing or let anybody else service a wheel like that unless they have the correct tools. This is my collection of spoke holders. I use all of them at one time or another. Here are a couple of Cyclist 4-sided spoke wrenches. The one on the left you can clearly see is 4-sided where it goes onto the nipple, and the one on the right you can see where I have ground off part of the tool to make it, for me, work a little bit better. Here is a wheel that has an aerodynamic fairing that has no purpose other than making the wheel more aerodynamic. There's no structural benefit to it. There is a bladed spoke which disappears into the fairing and continues through it and is attached to an internal nipple back here, so the access to the nipple is through the back of the rim. If I want to adjust the tension on the spoke, I have to put my bladed spoke holder here because none of those longer ones that will slide down the length of the spoke will fit through the hole in the fairing, which means that all of this part of the spoke here is unsupported. That means I can't take a wheel like this and rebuild it with DT Swiss Aerolite or Supeme CX-Ray spokes because I have no way of protecting the spoke during this portion down here. It will probably twist inside the fairing and you won't even be able to see it. I can still use bladed spokes in a wheel with a fairing, but I have to make sure that I use spokes that are a little bit wider or thicker so that they are less vulnerable to twisting. This is a Bontrager Aeolus wheel, which is another example of a wheel with an aerodynamic fairing, and you can see the spoke going through a hole in the fairing. These spoke holders that slide down the spoke and support it won't fit through the hole in the fairing. But these spokes are a little wider, so their tendency to twist inside the fairing is greatly reduced. If you're riding in the rain, of course, it's possible that water can run down that spoke and accumulate inside the fairing, and that's the purpose of this little weep hole, which allows a place for the water to escape.